All right, so how many of you have used the Arduino before, the hardware programming?
No.
None of you? Have you guys heard about that?
Yeah.
Okay, great. So today we are going to talk about that. So the purpose is not to make you an Arduino expert. So we are just talking about entry-level concept, but the purpose is to make you comfortable of trying your own Arduino project. So I'm just going to tell you the most important concepts about Arduino, and you will see how easy it is. So you can probably do something yourself. I'm going to turn my screen like this. So you will see what's going on. You probably wonder why we have a different angle today. Can you guys see my table now?
Yeah.
Okay, so this is something we will be talking today. And I will also share my, occasionally share my screens so you can see how I'm programming things. Okay, so let's talk about the hardware part of Arduino. Arduino is nothing but just a chip plus a lot of sensors you can use, okay? And so basically it is as easy as connecting the sensors. For example, this is an ultrasound sensor, if you recall. One is sending out ultrasound with certified, and the other one is receiving that, so you know the distance. This is render, right? So it's just as simple as connecting the sensors to this chip, right? And then you have this cable. Let me show you this one. So this cable, it's a USB cable. So you basically just connect one to your Arduino board, okay? And then the other one connects to your computer. It's USB. We have a different boards for Arduino. The motherboards for Arduino, they have different capacities and functions. This one is the most popular one, called Arduino Uno R3. So this one provides, as you can see here, the numbers here. I don't know if you can, I don't know, focus, please, focus. Can I just force it to focus somehow? Oh, this is too bad. Let's see. Okay, I don't know if I can force it to focus, but you probably see some numbers here. Let me get a pen. You see the numbers here?
Yeah.
I assume you guys can see, this is 0, 1, 2, 3, 4, 5, 6, 7. So if the numbers, if you just see the pure numbers, those are called digital outputs, okay? So basically it's giving out signals in the digital way. But on the other hand, you do see some other numbers. It starts with a letter A. So it's here's A0, A1, A2. A stands for analog. So this one is actually sending out what do we call the electrical potential, and also that is the voltage, okay? So it's sending out different voltage, use the analog signal to trigger things. So those are analog in, and digital out. And here you also have power. So this Arduino system, this Arduino motherboard will also provide power to the sensors. So you have 5 volt and 3.3 volt, and you have 2 ground. You guys know the volt one actually connects to the positive of your sensor, and the ground connects to the negative sensor. And then you connect the sensor. Most of the sensors will have something related to data. So for example, like this sensor, this ultrasound sensor. This is too bad, it just cannot focus. Hold on, let me use my phone. I guess I can use my phone to. Camera. Okay, so I need to camera device, sighting privacy camera. Oh my goodness. Sighting privacy camera. And the camera. Here it is. Okay, so I need to allow Zoom to access my camera. Here it is. All right. Join the meeting. Okay, how do I switch the camera? Here it is. I don't know if it's clear, but let's see.
Yeah, that's much clearer.
Okay, hopefully. So now you can see, for example, this sensor. This one actually shows the VCC that shows the voltage. So we connect this one to either the 3.3 volt or the 5 volt, depending on the requirements of this sensor. And this one shows the ground, so you know that's negative, so you connect to negative. So those two things provides power to the sensor. And you see this one shows trigger and echo. That basically shows that in your code you define which of the digital input or analog input you want to use to control the trigger of this sensor and to control the echo of the sensor, echo which means the receiver. That's how you connect things to it. Another example, probably a easier example, is this guy. You guys still remember this one? The vibrometer, right? So this one basically, if you price it, it changes the voltage, so you can sense the vibration of this table, right? And if you check this sensor, it goes S plus and minus. Focus, please. You see those? This is S plus and minus. Plus and minus means power and S means signal. So if in your code you define like any one of these both as the receiver of this S signal, then you will read that data from this sensor. That's how easy it is. Okay. So now let me show you how we program Arduino. Let me share my screen. Okay, so you basically just go to Google Arduino, and if you open this project page, and just go download, and you can download the Arduino Ide. This is the programming platform for Arduino. It's totally free. It also supports Windows and Mac. So just download the latest one, and I have downloaded already. Let me show you how it looks like. Let me open a new window here. This is how it looks like. Okay. Am I sharing my screen?
Yes.
Okay, but why this one is showing a different thing? You guys can definitely see my computer screen, right? Okay, my Zoom is doing crazy thing right now. Anyway, so here, this is how it looks like. The first thing you want to do is to, since we have so many Arduino motherboard, we want to change it to the one we are using. So as you can see, we have this one. And by the way, so you guys can see the ones, this to my phone, the screen from my phone, right? So this is the MGA Mega 2560. That's the name of this motherboard. So this one has 250K, 256K of memory. So that actually how much it can memorize, how much code it can build in, only 256K. And this one is even lower. This is this is only 32K. But you can actually do a lot with 32K memory. So we're going to use today, we're going to use this Mega 256. So then on the screen, you have to find the right one. So let's say I want to find this Arduino Mega 2560. And then let me hook up this Arduino. just going to insert that. And you see it start to flash. It means it's powered up. Okay. Oh, you can see both of my camera and my screen, right?
Mm-hmm.
That's helpful. You guys can reset the window as you want. And then let's go back to 2. There's another setup we have to do before you do anything, is the port. So it shows that, okay, COM1, COM3, that's actually the names for different USB connections. It actually shows that COM3 is connected to something already. So let's switch to that. So now I make sure I have the right motherboard selected and the right port selected. So everything looks good. Now, this is the coding, the UI for coding. Arduino code is actually very simple. You just have 2 parts. The first part is called setup. The second part is called loop. The setup means you define how fast you want to read the data from the sensor, the major variables you want to read. For example, the vibration or the power or the weight. You know, you define everything there. And the loop basically just repeat that. Okay, you repeat that, for example, 100 times per second, then you will receive 100 times data points per second. So now let's do the most simple project now. Let's connect this vibration sensor to Arduino and build a code to read that vibration, okay? So I'm just going to find a new project. Where's that? Here it is. Okay, so let's use this one. So the first one we always need to define is the serial begin. So this one shows that it's telling Arduino I want to begin my project or my sensor reading. And we need to define the bandwidth for reading. So let's use 9600, that's a BPS, bytes per second. So 9600 is the default one. It means that, okay, I'm going to ask Arduino to send and receive data at 9600 bytes per second. So that's what we need to define. So once this one's done, let's go to the loop. So that's the only thing we need to define for now. So let's do this integer, and let's define a variable called v, and we use the function or method called analog read. So which means we want to read data from the analog part of the Arduino motherboard. We want to read data from there, and we want to define which analog output, which is A0. So like I mentioned earlier, you have so many analogs and you have so many digital outputs. We want to define which one with the else and A. This one, if you guys know Java or C#, this is how you define the type of this variable. So for this one, we just want to use the integer. So we just use int space and we give it a name. Okay, so now the Arduino knows this is just an integer and this is the type of that, and this one is from this method and from this analog output. And then we want to print that. So once again, we want to use serial. We also want to print function, and want to print line, which means I just print the lines of data. And print what? Print this v. Believe me or not, that's everything you need to do for this project. Okay, so now let's connect them. Okay, so let me stop sharing my screen for now, so you can see this view clearly. Okay, so now let's recall. So this black cable, usually we connect a black to the negative, which is the ground, and collect a right wire to the power, okay? So this is the negative, and we want to connect this one to this label called GND, which is ground. So let's connect it to the ground. And then let's connect, usually we want to connect the signal one first before we connect the power. Make sense? So now let's connect the signal, which shows the S. This one shows the S. And let's connect to which output? A0. Because in my code, I want to read things from A0. Make sense? So I'm going to connect to A0. And finally, I want to connect to 5 volt because I know this sensor works with 5 volt. Okay, everything's connected. It just looks like this, okay? And I have this sensor connected to my Arduino. All right, so now let me go back to my Let me show you a clear view of that. I hope this helps. You see, you know, the black cable connects to ground, and the positive connects to 5 volt. And the data cable connects to A0. Make sense? Okay, now let's share my screen again. All right, so then you can verify basically, you know, just check if there's anything wrong with your code. Of course, ask you to save that. So I'm going to say web sensor test 1. All right, so now it's compiling sketch is doing the verification to see if your sketch is correct, done compiling, and then you can burn it. You know, we call it burn, we call it upload, but it means we are sending the code from this computer to my Arduino motherboard. That's how we use their memory, okay? So let's just do this compiling sketch. You see, basically this code is only 2K. So it's 2,000 bits, that's only 2K. It's about 0% of the storage, but you know, the overall is the 256K, okay? And then let's go to tools and go to serial monitor. You see if I touch my table, you see the number is changing, right? So now Arduino is actually reading data from my sensor right now. So if I go to tools and plotter, it's clear like I'm touching my table. Make sense? That's how it works. And probably this is refreshing too fast, right? So we can just simply go here and use another function called delay. And let's say, delay, this method, you basically put the millisecond, which means instead of the maximum bandwidth read of data, I want to read data, let's say every 100 milliseconds, okay? And once that's done, we want to burn that again, which means we refresh the memory and see this is uploading down. And let's go back to the monitor. You see, now the refreshment is much slower because it's refreshing like only 10 times a second. Make sense? And if I go to the tools plotter, you can also see start to slow down, give you like a better view of the vibration. That makes sense, right? Okay, of course you can make it you can add more codes and to make it better. So let me just close this one. Let me see which one we're going to use. Okay, so this is the one that I created with also some kind of UI. And let me just help you understand what that means. Can you guys see the screen clear? I really want to mute my phone. It's really annoying doing this. All right. Okay. So this one basically shows that, yes, I also want to use this refresh rate, 9600, but I initialize something, I give it a name called a PLX data queue, okay? And this is a loop, and I just say, you know, I define another thing called write data queue. That's a method I define, and I give it like an output for, this is 1 means 1 millisecond, but I can change it to, let's say 100, okay? And so see, I gave it a name, but I need to define what I mean here. Makes sense? This is actually how we organize Java code or C# code. You know, it's a clean way to organize your code. You define something or trigger something, you trigger method here, but you basically give the details of the method later. Make sense? So let's say we have this initialize PLX DAQ method. That's the method we created. And here you will see, this is what that means. Basically, I want to print the headline of my data. I just want to do it one time, which is the clear date, label, time, and vibration. I want to make my result better. So this is how I call it initialize data queue. So Arduino knows this is what I want for this method, and I trigger this method at the very beginning. Make sense? And then I also trigger, see here, I trigger this method called write PLXDAQ. And what that means, I define here. It basically shows that I want to read this data from A0 and I want to print the following. So I want to print something called data. I want to print something called time. I want to print something called V, but I also use the comma to separate them. And why I can show data and time, those are the default variables in Arduino. So when you just type data, if you see the color is changed, it means, oh, that's something Arduino understand. It wants to show the data, time, and everything. So let me burn this one to my board. It's compiling. And then let me open the monitor. So basically it shows, you know, data, time for you. And if you plot it, it will still show the thing that is changing. Okay, so this is our first ever Arduino project, and I hope, actually, if this was a face-to-face project, what I'm going to do is I have 4 sites of Arduino. I'm going to give this to you guys and ask you guys to program and play things around. But I guess I can only do demo today. Okay, so this is our first project. We just did this. Vibration sensor, very simple, right? Any questions so far? You probably already got the point, right? So power and the data, that's all you need, right? That's how you connect that. This is called a female, this is called a male. And so this is one side is female, one side is male. All the males go to the motherboard and all the females go to the sensor. That's always how Arduino system works, okay? Question, guys? Comments? Nothing? Let me see what else we want to do now.
I have a question. When we do the readings, the system should be connected to the computer, or we can like collect data and then connect it.
Oh yeah. So for this task, I basically connect to the computer so we can see the result immediately. But there's also data logger. So I don't know if I have data logger here. Let me check. Anyway, so there's a data logger that you can connect to this one, and it's basically save the data temporarily for you. And this USB cable, the reason I'm using this is for demo, it sends data and it burns the code very easily. It provides power, but of course, you can also connect this power cable to this power outlet here. Or if you have a power bank, you can connect to it, or just some batteries, you connect to it with supply power, and you connect this one to the data logger. It's a separate system. Makes sense? And it's not expensive. I think this Uno system is only like $7 or something on Amazon. You can definitely play that. And this this vibration sensor is $4 or $5 for 4. You know, it's kind of like $1 each. It's actually pretty cheap if you want to have your own project. Okay, so now let's do another project. This is a temperature and temperature and humidity sensor. Let's use this one to read the temperature and humidity in my office. Okay. So I often disconnect it after one project, so I don't mess up my code or have it burn. And I already connect this one. Okay. So now let me find. And talking about how you should connect them, there's always instruction telling you which should be connected to what. Like for example, for this one, it doesn't provide any label. It's empty. You even don't know what is the positive, what is the negative. Of course, you will burn it, right? So then you can just go online, search the model number, and you will see that. For example, for this one, this is how you should connect that. I'm going to show you the schematic layout of that. Let me see, open class, PPT, Arduino. Temperature, here it is. And let me share my screen. You know, this is how you should connect that. It shows that, you know, the first one is data, the second one VCC is what? Is the positive of the power, ground is ground. And it also has this kind of a figure for you, and it's actually very simple. And this one is using UNO, but of course we can use Mega 200, 2560. That's not a problem. Okay, so the key point here is we also, for Arduino, we also have a lot of finished library. You know, then you do not need to code each line. You just set the library, then you can get it working and running. Let me show you how it works. Okay, so here, let me show you what it means. This one, at the very beginning, it shows that a simple dth.h. The H actually means some established memory, library. You have to load the library to be able to run the following code. Why? Because inside the library, somebody already coded all the functions you need. So for this particular sensor, you know, this sensor has a lot of positions, you know, like locations. That's a it's not the 10-digit system, it's a 6-digit system, 16-digit system. So this library actually tells Arduino where to find what data. So we do not need to code each line, but we have to set it. So how to do it? Go to Tools, Manage Library. We're not sure if we have the library built in. Let's search for that. Okay. And let's just type in. You guys can see my screen now, right? So simple DHT library. Now we find it, and let's go install. Installing, close. Now we have this library built in. So basically download that library and load it. And then this one shows, you know, the voltage. You know, this is actually whoever programmed this one is very nice. Let's just show, okay, this sensor works with 3 voltage. Don't use 5 voltage. And since I use the second as the, you know, 2 as the data, so please connect it to 2. It doesn't start with A, it means what? This is a digital output, so it uses digital 1, right? Okay, setup, once again, this is the first part of that. We define the bandwidth, the speed of that, and then we define a whole bunch of variables. And this time, in order to save the space, we didn't use integer, we use bat. And so temperature is a type of bat, and we give initial value 0. Humidity, we give the initial value 0. And this one is required by this particular sensor. You must create a 40 batch long array. So even though you don't have the complete data, but you have to create a 40 batch long array, and the initial value is 0, and they just basically write numbers to that array and show that. And it shows that if there's number from your like motherboard output, here we define that. So this is actually where we are going to read data from, and then print, you know, let me see this one. Oh, so if there's nothing, then print failed. If there's any data from this particular pin, you know, the output pin on your motherboard, then we just return, which means return the numbers, and then we print out the numbers. Make sense? So this one is an evaluation, like, do we have data from this particular pin, which means this particular output on this motherboard? If no, then just say failed. If yes, then return. Return means I read the data. And then finally, I print all the data from there. And I use delay, which means I don't want to print one data point. I don't want to print 1,000 data points per second. I just want to print 1 data point per second. This is temperature, right? It's okay. So I just change it to 1,000, which means 1,000 millisecond. And one thing, what else we need to know? Okay, here it is. This is very difficult to understand, but I want to just show that to you guys a little bit. This is simple DHT11 is something we loaded from the library, right? This is something called a class, okay, a class. A class is a package of a lot of existing methods, of a lot of existing variables. Imagine that way. So it's something, somebody created a lot of functions and packed them as a class. Now, if I want to use it, I load it first, and then like, remember how I load it? I use this manage library, I load it, right? And then I have to create an instance of that. So this one is I put the name of class and I put the instance of that. And then all of a sudden, after this line of code, the instance view have all the methods and the variables from the class. This is called an inherit. So I inherit all the methods and the variable from the class. Make sense? And since I have all the methods from this class, this is DHT11, I can use that in this way. So DH11.read. Now it understands what this code means. I just basically cite the method read from this original class. Make sense? So now imagine this class can be people, and this particular variable or this particular instance can be Eric. That's me. So it's kind of like a people Eric, and the people has the functions of what? Eating, walking, sleeping, right? So then in order to set a function, I can be Eric.eat and something. Make sense? So this is actually the object-oriented programming. This is the basic of that. So in this way, the difficulty part for this code is we loaded the library and we instantialize that, which means I create an instance of this library, of this class, and then I can just I'm free to use all the methods of that. Okay, so now let's connect them. Let's open the how we should connect that. Let's open the schema map of that. Let me see, class, PPT, Arduino. Okay, so now if I put this way, this is the one. Let me stop sharing my screen, but you guys can see this map, the layout here, right? Or configuration here. So I'm going to stop sharing, and I'm going to just, I just did this thing. So okay, so this one, this green one is the ground. Okay, so the green one is the ground. So let's connect this one to ground. And let me see, this is central one, this right one is power. Do you guys still remember what power we should use? 5 or 3? For this one, it's 3, right? So we shouldn't use 5. A little bit. Okay, so let's connect this one. But remember, we always want to connect data first. Remember which data port we use for this, which data pin we use. Number 2. Make sense? So that goes from number 2. Not the one start with A, but just number 2. And then this positive, let's connect to 3. This is how it looks like. Okay, so since in my code, I use number 2, so I connect my data to number 2. Of course, if I change the code to number 3 or whatever other number, I can always this phone doesn't help, so let me just shut it down. And my phone is kind of like burning. I don't know if this helps. Yes, so I basically connect this data to the number 2 since I wrote it in my code, and I connect this black to the ground, and this positive to 3.3. All right, so I connect everything. It looks good. And I'm going to hook it up. All right, and let me share my screen. Okay, let's burn it. You can skip this verification step, just burn it. Compiling and uploading. Oh, see, I forgot to set up, since this is a new one. So go to Tools, select Mega 2560 and the port to COM3 and redo that. Uploading, done. And let's go to monitor. All right, so that's the number in my office right now, 23 degrees Celsius and 43% relative humidity. Okay, and of course you can use the plotter. But it only shows one. This is temperature, that's the humidity. Just give it a second. Maybe this is too slow. It's okay. We can change it to 100 and burn it. So that's 100 millisecond. And go to plotter. It's still fairly slow. This one shows relative humidity, but I don't know why that one is gone. Let me change it to 1000 again. My temperature is gone. Yeah, this is chip sensor. I don't know what's wrong with this one, but you got a point. Oh, it's actually, I use my hand to push it and the relative humidity just increased because my hands are white, okay? All right, any question for this one? I think for this one, oh, you can see my screen, right? For this one, the biggest part is you need to know how to load the library. And after load library, how to create an instance of that, and then start use the built-in functions, built-in methods of that. Make sense? Siri by itself is actually the default class in Arduino. So that's why we can just, without setting anything, we can start using that. The serial.begin means I'm going to use this method begin from this class Siri. Make sense? Question for this project? Anybody?
No.
All right. I really hope you guys can try it yourself. You have to touch it and feel it. It's actually very, very interesting. All right, so let's do another project. Let's use this render. This one can check the. This one can use the ultrasound to track the distance. Okay, so if there's obstacle, there's a distance. Let's do this one. All right. So let's do the code first. Instead of writing the code, I'm just going to open my existing code. Ultrasonic. Okay, I'm going to hide some code. I want you guys to somehow participate in this one. All right, let's share my screen. Okay, so this is the code that I have, and can anybody let me know? I'm going to ask you guys some questions, and I want to see who can answer the question. Okay. Can any of you tell me the meaning of this code? Phew, it's here. Can anybody tell me what's the meaning of this code? Int trigger pin equals to 11. This code is doing what?
You're setting an integer trigger pin. You're setting trigger pin to 11, which is an integer value.
Okay, that's great. And that's probably, will be used later. Like for example, here you see I'm reading something from this trigger pin. Why don't I just write 11? Because sometimes if your code becomes so complex, you want to change it in one place and all the other will be changed. Make sense? So let's say I'm using 11 as the trigger pin for this project, but for some reason the 11 is being used. I want to change it to 14. But if I have a lot of code, I have to manually change every single line of code to 14. How about I just I named this variable and I gave a value 11 to it, and I just use the trigger pin all the time. So I change the number here, it will change everything automatically. Make sense? Okay, so similarly, what's the meaning of this code? Anybody?
You're setting another value to 12 instead. It's
Echo pin.
echo pin.
Remember this particular sensor, one is sending out the signal, one is receiving. So one is trigger, one is echo. Make sense? So this one is telling me I need to connect 1 to 11, 1 to 12, right? So I just define that number. And this one is double duration, centimeter and inches. What does that mean? These are all the results I need, and I gave them the data type called double. What is the difference between double and integer? The double means you can have a lot of a decimal number, right? So it's kind of like 1.2356. You know, double means 16. I think double is 8. Yes, double is flow 6. It's 16 digits after the point. So we know that the number we will receive for example, distance wouldn't be an integer number. So that's why we define the data type as double. Similarly, we're going to use another function. We're going to use this ranger, this ultrasonic ranger, to control a small fine. And the fine is controlled by the power sent out by the Arduino motherboard. So that we will talk about later. And this is once again the setup one. And this one is defining the bandwidth. And what's this meaning? Can anybody guess what's the meaning of this one?
You're setting trigger pin as your output and echo pin as your input.
Exactly. So what I mean is for the Arduino motherboard, each pin can be either trigger or output. So this one is telling Arduino that I want a trigger pin, which is 11, to be an output. So which means what? It's sending out signal. Make sense? And I want this echo pin, which is 12, to be input. So it's actually receiving signal. Make sense? So this is actually, you are defining this into the pins on your motherboard using this pin mode. The pin mode is actually a method. Right, so I use the pin mode method to tell Arduino, please, 11 is output, so it can send out this kind of like a zigzag signal to the sender of my ultrasonic sensor, and the 12 is receiver, so this one is receiving and documenting, logging the data. Please do that for me. Okay, so this is how it works. And now this is the first part of the code. It's defining everything for one time, and this is the loop, right? And now I can see what this part is meaning. And now try to recall what we learned in the sensor class. I don't know if you can make it bigger. Yes, this is much better, right? Okay, so can anybody tell me what this is?
The length of the curve, the length of the pulse.
Yes. Remember when we talk about this? Yes, I think we're on the same page, right? I mean, I think you know what that means. But let me show you about this, which is this one. Remember, in order to know, you know, like this echo part of this sensor, it needs to know like which bounced back ultrasound is receiving. So we need to have, we shouldn't send just a continuous ultrasound. We want to have some pattern in the, or some pause in the trigger part. So basically the ultrasound is doing something like a up and down, and up and down, okay? So this part of code you see here is actually defining that pattern, right? So I'm just defining, I'm going to write a signal as low and the second microseconds 5. So it lasts a low level of ultrasound for 5 microseconds and high for 10 microseconds. So I'm creating that kind of a zigzag. I'm creating that kind of a zigzag pattern in my triggered ultrasound. Make sense? Okay, and everything, once again, this digital write is a method because I define this pin as output, and so this trigger pin is recognized as output, so it knows how I should, what kind of power I should trigger from this digital pin on the motherboard. Make sense? So this part is defining, the trigger pulse pattern, and this is doing what? This is calculating the received signal. Centimeter is duration divided by 2 divided by 20.1, 29.1. What does that mean? Duration is what? So here this function actually reads duration from the signal, from the high part of signal. So this is duration, which means this is the duration traveled from my trigger and to the object and the bounce back. This is duration. And this is a formula based on the speed of sound in the air. And we convert that duration into centimeter. Make sense? Or we have another formula for inch. It's just centimeter and inch. Make sense? And then we have a whole bunch of parent. And then I delay 100. What is the meaning of delay 100? Anybody?
To reduce the number of readings?
Yes. To how many? To 1 data point every 100 millimeters. So that's how many data points per second? That's how many data points per second? 10.
Okay.
Right, so 1 second is 1,000 millisecond, sorry. So, okay, let's connect that. So this is actually very clear because this is labeled. So I'm going to just stop sharing. And hopefully you guys can see that a little bit. Let me use my flashlight. It's kind of focus. Okay, I hope this is working. Anyway, so I can tell you this one is VCC. So let's say that this one, this gray one is showing GND. So I'm going to connect this one to ground, right? So that's the negative of my power. So I'm just connected to ground. All right. And now this blue one shows ICO. Do you guys still remember what is the number for ICO? 12, right? So 11 is trigger, 12 is ICO. So I'm going to find the number 12. So I'm going to connect to 12 like this. And this brown one shows trigger. And what's the number for trigger? 11, right? Yes, let's connect to 11. And finally, let's connect the power to, what is the power we should use? Then we have to check the specification to see for this particular sensor, what is the power they ask us to use. I'm going to check that. I'm not going to show my screen, but I'm just going to check it myself. Arduino ultrasonic. So it shows the power should be 5. So 5 volt. Okay, so I'm going to connect this one to 5. Make sure everything is connected, and then let's hook it up and burn that. So I'm going to share my screen again. Guys, teaching Arduino online makes me really busy. So just burn it, compelling. Oh, once again, I forgot that. So let's go tools, Mega, and to port COM3 and burn it. Uploading. It shows only 1% of the memory, so you can do a lot with just 250K. Just imagine that. All right, so let's check the monitor. See, I don't know if you see, I move my hands over there. I see the number is changing, right? So I'm just going to use the plotter. You can see that clearly. Oh, it's not plotting, I guess. It's got confused because I have two different things. So let me just note. You just use the two lines to hide the codes like this. Now I'm going to print. Okay, so I'm going to use the centimeter. So I'm going to just hide inches like this. So I don't need an inch. Centimeter. Blah, 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 blah. Here it is. All right. Let's see if this works. Something's wrong. Can anybody tell me which part is wrong? Print inches, centimeters here, inches here, but I have inches, inch. I don't need that. Centimeter, centimeter, and print line. Oh, it's just totally gone. Why? I don't know why it's doing that to me. But anyway, you can see the maximum range for this one is around 167, 170 centimeter or 66 inches. But if I move my hand closer to it, see that number is becoming smaller. Oh, here, right? So this one can basically tells the distance of things. Imagine what functions you can realize with this small sensor. It's actually another very cheap sensor. I think it's $5 or $6 on Amazon, and it can probably build a lot of this stuff and do some warning system, or maybe even use this one to build a 3D model of something. I don't know. Just use your imagination. You can do a lot of things with that. But now let's do a cool stuff. Instead of using the Syrian, how about this? Let's realize the function. When something is closer to this one, it will trigger some kind of voltage and trigger something. Last year I used the Syrian, but the Syrian was so loud. So I'm just going to, this time I'm going to use a small fan. So I have this motor. Once again, this is something you can also buy on Amazon. I'm going to just stop sharing my screen. So I'm going to use the motor, and this is a small fan. I'm just going to connect them. And once again, you see two cables, two wires. One is black, one is red. Which is negative?
Black is negative.
Always the black one is negative. Remember, this is the rule of thumb. This is standard. We always use the black color to represent ground or negative. Use the red color to represent the positive. Okay. So this is a 5-volt motor, and we want to add something to this code. Since we are running out of time, let me just show you what I want to do, okay? All right. Can anybody tell me what this means? Just guess. This is called analog write. It means it's writing something to some place, and the value of that is this. So what I mean? Okay, so the analog means power. So basically, it's voltage. Arduino can generate 0 to 1024 levels of voltage. Let me repeat that. So for all the pins on Arduino, if you see starts with A, they are only reading or writing or sending voltage, and they cut it into 1024 levels of voltage. And so this analog read means I'm sending out a voltage. And that voltage, and sending out a voltage from this, through this A0 analog pin, and the value is this number, okay? It's called a power out. How do we define the power out? It's based on the centimeter, okay? Why I'm doing this? Because I'm doing the normalization. The range of the voltage and the range of the distance are so different. Remember, I mentioned that the distance, the maximum distance for this ultrasonic sensor is what? It's around 160 centimeter. But the level of voltage is what? It's 1000 something. Remember that? So I'm just going to scale it up. So I times 5. This is the something I read it from it. And if this is bigger than a certain number, I don't want it to be too much. So I just fix the upper limit of the power. I don't want to burn my motor. So I give it a 250. And then I use 250 minus that. What I mean? It means if it's closer, the power out number will be smaller. Then this number will become what? Will become bigger. So if I closer, this motor will receive more joules and the fans will rotate faster. Make sense? That's how, that's how I realize the function. When my hand is closer to the sensor, then I'm making this number bigger, or the A0 is sending more joules out, so the motor will rotate them faster. Let's see how it works, okay? So the black should be connected to where? To the ground, right? So we have 2 ground. So let me connect to the ground. And then the right of this one should be connected to 5. Oh, we don't have 5 now, we have 3. So let's just use 3. That's probably will slow down the motor a little bit. Okay. Okay, so we haven't built the code. Oh my goodness, I need to build the code. It's rotating because, oh, I was wrong, sorry. That's totally wrong, I shouldn't do that. I should connect this red to where, sorry. Guys, I should connect this red to where. If you understand the code, where should I connect the right wire from the motor? Anybody? Remember, I'm sending all the joules through this A0. So I shouldn't connect the wire directly to the 3-volt pin. I should connect to what? A0. So that's how I can use my ultrasonic sensor to control the joules to the motor. Make sense? Let me do this. So I'm going to connect this one to A0. Now see how it triggers that. If I move my hand closer to this, now you can see how it works, right? Did you see what's going on here? That's how I trigger that. So what I did was wrong. I just basically connect this, this is the motor, the power of the motor. I direct connected to the 3-volt of power supply. Then it will supply continuous 3-volt joules to the motor. That's not what I want. I want it to be controlled by A0. Make sense? Let me see what else we can do. How about, okay, I still have some more projects I want to show you guys. For example, this one can read the depths of water. I actually have the water ready. And so you merge that in the water, you can read, the level of water, because water will change the resistance of this panel. And so based on that, I can see the depth of water. And I have this really cool sensor. This is a $5 sensor. it has gyro sensor built in, accelerometer sensor built in, and also have a temperature sensor built in. So if we do that, if you mold it to a hand, if you move your hand, if you plot that beautiful curve showing how you move your hand and how you get everything. Everybody's phone actually has such a sensor built in. Okay, let's do that next time. But before that, any question about Arduino? Are you guys feeling a little bit more confident of trying your own Arduino project right now? I cannot see you guys, but I hope. So now, I think the key point is it's not difficult, right?
Yeah. Do those Arduino kits come with like basic instructions for C# and whatnot?
What do you mean by
just because besides the pre-made code modules, like to learn C#, do they come with it, or?
You mean like tutorial?
Yeah.
Yes. Actually, let me show you this one. This is the one I downloaded online. Let me share the screen. It basically, you can download this tutorial online, and it tells you how you prepare everything, like how to install this IDE. That's fairly easy, and talks about different modules, like how you create, how you control RGB, digital input. And for example, we talk about this this temperature and humidity sensor. If you open that, if you show you like how you should connect everything, okay, and also it provides the sample code. You just double click that. If you open this IDE and with the sample code, it's just a matter of you need to understand what I mean, right? That how you should load this library, and then how you set the methods from the library, and also it just give you more examples like that, and also have some advanced function, like if you want to combine multiple sensors together to create some kind of like for example, use the ultrasonic sensor to trigger the little fan. That's kind of like combining multiple components. And finally, they have really cool and really advanced functions. Something that I really wanted to try this year, but because of COVID-19, we cannot do. See this one? This is RFID. So actually it provides the RFID reader, and it has this little pen for yourself. You can basically, if you do this project, you can write a personal information into this one and carry it with you, and hook up this RFID with, I don't know, with some smart lock or with something. So when you go home, it sense you are home, it opens the music or something for you. Just some cool stuff you can do. This one is called a starter, the most complete starter kit. This is fairly expensive, about $50. It's okay, $50. And I have this, the starter one, but this one also has a lot of functions you need, really good. With a Uno and a Mega, this is $20. So with $20, you can buy a lot of stuff with a lot of sensors and various you can use. So, if you guys want to remember, it's also time for you guys to think about your final project. So this class, we have a final group project, right? So if you guys want to do some cool thing with Arduino, you can buy things from Amazon, or I'm very happy to loan what I have. You just don't have to spend the money. Just don't forget to return by the end of the semester. All right. Any question, guys? No? Okay, I guess, and then see you guys next week. We will finish the two sensor project next week, and then we will move to data analytics. So this one concludes the sensing part of the class. All right. See you guys later. Bye.
Thank you.
Thank you, Professor.